guys, hope you are doing well. In a new session, I will be talking about the chapter 4, section 2. We'll be talking about the driving forces of the reaction. Let us start and talk about the driving forces. Guys, in the previous section, we talked about the enthalpy change and enthalpy of formation and combustion and the reaction. We said the enthalpy of reactions whenever it's exothermic, the tendency of the reactions, the tendency of spontaneity according to enthalpy is toward the exothermic side. Let us provide some revision for the enthalpy, and then we'll be talking about the second driving force. The enthalpy is the first driving force for the reaction, and the second one is the entropy. We'll be talking about it in detail. Guys, the enthalpy, according to the enthalpy, the tendency of the reactions in nature are toward the minimum enthalpy. Toward the minimum enthalpy, we mean the exothermic direction. So whenever we would like to, we wanted to determine the direction of favorable direction based on the enthalpy change, the exothermic direction should be the direction which favors the reaction. The great majority of chemical reactions in nature are exothermic. Most of the reactions which naturally occurring, spontaneously occurring, are exothermic reaction, guys. So most exothermic reaction occurs spontaneously because the tendency through the nature is for a reaction that process in a spontaneous direction. Most of the exothermic reactions are what are spontaneous. Spontaneous, we mean occur without having or exerting any external force on the reaction and the system to process. In exothermic reaction, energy is liberated and the products have less energy than the original reactant, and products are more resistant to change and more stable than reactants. We talked about this in the path of the exothermic and endothermic reactions, guys. We said the exothermic reactions, because of losing energy, if the reactant is situated here, the product must be in a lower position of energy. Why? Because from the reactant till we reach to the product, there will be losage in energy. That's why the product should be in a position which is lower than the reactant, and a lower position of energy is more stable than the higher position of energy as well. And then, guys, with the exothermic reactions, we have endothermics. Endothermic reactions usually cannot occur spontaneously. So the exothermic reactions occur spontaneously, but the endothermic, they are not occurring spontaneously because energy of reactant is less than the energy of the product. But some endothermic reaction occur spontaneously, such as melting of ice. So do we have any endothermic reaction or endothermic process that occurs spontaneously? Yes, of course. Suppose we have a piece of ice, guys. The piece of ice at room temperature, at 25 Celsius, melts without providing any heat to the piece of the ice at room temperature. The piece of the ice spontaneously melts. What's the process of the melting? Of course, the piece of the ice must absorb heat from the surrounding, absorbing heat from the air and then melts. So this process of absorbing heat is endothermic. as it's endothermic and spontaneously. So this is an example which represents there is possibility for the endothermic reactions to be spontaneous. There is possibility for the endothermic reaction to be spontaneous. And this, we can conclude that something else, that enthalpy change must help to determine whether a reaction will occur spontaneously or not. So the enthalpy is not the only factor, is not the only driving force behind the spontaneity of the reactions. Something else must be taken into consideration for the spontaneously. That's the entropy. So in chemistry we have two driving forces, one enthalpy, the other is entropy. So we will be talking about entropy in detail. Let us talk about entropy and what's entropy and how to determine the sign of entropy as well. Entropy and reaction tendency. Guys, entropy represents the degree of randomness of a particle in a system. What do we mean by the degree of randomness? Whenever something is arranged in order, in a well-ordered arrangement, that has the least entropy. But if it is randomly moving or randomly, or there is disordered particles in a system, that has a high entropy. So the entropy is a qualitative measure of the degree of randomness of particle, such as molecule in a system. A system with lacking of order has high entropy, but the system with order has order of particles in the system has a low entropy. Randomness of particle in a substance depends on crystal structure and motion of particles in that system, guys. If the structure is crystallized, that means it has, like solid is, it has the least entropy. But if it's amorphous, like the liquid, like the gases, its structure is amorphous, that means they have a higher entropy. A lower order and a higher entropy. And as the motion of particles in a system increases, that increases the entropy and decreases the orderness of the process. A random system is one that lacks a regular arrangement of its parts. So whenever it has a lack of regular arrangement, we mean lack of the orderness, that's a high entropy system. This tendency, randomness, is called the entropy of the system. As energy added by increasing temperature, guys, what will happen to the degree of randomness? Guys, whenever we add energy to a system, that increases the kinetic energy. Whenever we add heat to a system, it increases the kinetic energy of the particles. And the kinetic energy of the particles lets the particles move much rapidly than before. And then as the kinetic energy of the particles increase, the temperature increase, that increases the entropy as well. So the crystal structure changes into liquids or so gases. The solid crystal changes to liquid and gases, and the randomness of the molecule motion increases, that increases the entropy. As the motion of particles increase, that increases the entropy of the particles. We have to know that when the entropy is zero, in which case, when a pure crystalline solid is at zero or at absolute zero temperature. Absolute zero is 0 Kelvin, guys. 0 Kelvin or minus 273 Celsius. This is the temperature that a pure crystalline solid reaches to a zero entropy. Why? Because at this low temperature, the motion of particles, the particles stop from moving around themselves even, and then the pure crystalline solid has no motion in between the particles. That's why it results as a zero entropy. Entropy symbolized by S, guys, as enthalpy symbolized by H. And as we measure the enthalpy change, we can measure the entropy change. But we do not have calculations in our book in order to measure the entropy as the enthalpy. Entropy delta S, which is entropy change, is defined as the difference between the entropy of product minus the entropy of reactant, and the unit can be joule per mole Kelvin or kilojoule per mole Kelvin. The preferred one, the more commonly used one, is kilojoule per mole Kelvin, and this can be stated as the equation entropy of the product minus entropy of the reactant, as the enthalpy of reactant product minus enthalpy of reactant. How to represent an increase in entropy? Of course, by a positive value of delta S, we mean the entropy of a system increase, and by a negative value of delta S, we mean the entropy of the system decreases. How about tendency in nature is toward which side, guys? Tendency in nature is toward a positive entropy. So, according to entropy, which direction of the reactions favors to a spontaneous process? Favorable direction is a positive entropy. A positive entropy. Guys, generally, the solids, they have a higher they have a higher order of the crystal structure than the liquids and gases, and lower entropy than the liquids and gases. But this we have some exceptional cases, guys. A general but not absolute rule is that the entropy of liquids is larger than the entropy of solids, and entropy of gases is larger than the entropy of the liquids. We will be talking about those processes, but this rule must be used with caution. Why? Because we have an example that mercury is liquid, the liquid mercury. Despite of being liquid, its entropy is much less than some of the solids. Its entropy is less than some of the solids. Another note about the formation of the solutions. Usually the formation of three solutions or three mixing between three mixtures will form what a process that has a positive entropy or increases the entropy. The process of formation solution increases the entropy. Why? Because an increase increases the randomness when we increase the entropy. This is true for what? For three formation of the solution. Mixing two gases first, dissolving two liquids in each other, and then dissolving a solid in a liquid. Mixing two gases like what? An example, like N2 plus O2. Mixing, just mixing, not reacting. Okay? Here, the N2 added to the O2 or O2 added to the N2 system. As we add gas to other gas, the number of the particles of gases in the system increase. So the collision between the gases increase, and as the collision between the gases increase, that increases the movement, the motion, and increases the entropy as well. Another example, liquid in liquid, like ethanol in water. Ethanol in water, guys. The same when we add ethanol into water, it will form a solution, and the movement of particles will be much rapid than these two liquids alone. That's why it increases the entropy. Dissolving solid in salt in water, guys. Solid in liquid. So, example, sugar, when we dissolve sugar, salts, the solid compounds in the water, they will produce a solution that has a higher entropy than the solid form. Guys, we have a note here. The entropy, according to entropy, the direction of a favorite direction results a positive entropy. We said before that the favorite direction according to the entropy is positive entropy. Guys, for the determining the sign of entropy, we have some cases, 3 cases. The first, by physical state, can be determined. If physical state, solid, liquid, aqueous, and gases, guys. In this direction toward the gases results a positive entropy. In the reverse direction toward the solid, it results a negative entropy. So whenever the solid goes to liquid, liquid aqueous, liquid gaseous, solid aqueous, it results a positive entropy, or the reverse process, it results a negative entropy. Why? Because the movement of particles in the gaseous state, because the gases, they are apart from each other, we do not have a strong attraction between the particles of gases. They move freely in a system, and when they move freely, the random motion of particles increase the entropy. But when it becomes aqueous, the motion of the particles reduces more. When it becomes liquid, reduces more. When it becomes solid, it's the least motion between the particles. Sometime in Ministry of Exam question, or the questions will provide what? Will provide the processes. So let us define those processes. A process that a solid converts to liquid we call as a melting. Liquid to gas is evaporation. Solid to gas is sublimation. The solid to aqueous, dissolution or dissolving. Another process, all these processes, they have a positive entropies, guys. The freezing is liquid to solid, gaseous to liquid condensation, gaseous to aqueous dissolution, gas deposition is gaseous to solid, or precipitation aqueous to solid. All these, they have a negative entropy. They have a negative entropy, guys. So in general, we can say that the solid has orderness increases, randomness decreases, so it has a negative entropy. Location of particles can be found, but in gases, disorderness increases, randomness increases, a positive entropy results, and location of particles cannot be found. Why? Because moves freely. The cases for determining, 3 cases for determining the entropy of a reaction, guys. Usually the reactions in exam, in the questions, will not be provided the entropy is positive or negative. You have to find the sign of the entropy by yourself through 3 stages, or through 3 predictions. First one is by physical state. The first is by physical state, guys. So the first is what? Is by physical state. If in the reactant to the product, solid goes to liquid, liquid to gas, liquid to aqueous, aqueous to gas, this results a positive entropy. If the reverse, results a negative entropy. Have a look, guys, on this reaction. This is reaction or decomposition of ammonium nitrate. Solid goes to gas, to liquid, to gas. So solid to gas, different physical status. If solid goes to liquid and gas, that results in what? A positive entropy. So the entropy of this reaction is positive. Why? Because the solid goes to gas. If it's the reverse process, it results in negative entropy. Second, guys, if the state, the physical state of reactant and product are both equal, what should do? We have to pass to the moles. Gas, gas, gas. So here we cannot determine the sign of the entropy through the physical status. Instead, we have to count the moles of the gaseous in the reactant and the product as well. How many moles of gas is 1 plus 3? We have 4 moles, and here 2 moles. Guys, from high mole to low mole, when a high mole means high amount, reduces to a low amount, that will be what? That will reduce the entropy of the system. So this process has what? Has a negative entropy. But if it's the reverse process, from a low mole to the high mole, it results a positive entropy. So in above case is what, guys? The 4 goes to 2. So high goes to low, that has a negative sign of entropy. The third, if the physical state and the amounts of moles equal, what to do? What to do? Let us have a look on this, the third case. S2 plus I2 form 2HI. Gas, gas, gas. So by physical state, we are not able to predict the sign of the entropy. How many moles of gases do we have in reactant? 2, and in the product 2. So by the moles also, we cannot predict the sign of the entropy. What to do? We will follow this strategy, guys. If the element in the reactant goes to the compound, as this example, S2 and I2 elements form the compound. So two species, they combine to form one. This is the same as the number of the moles reduces. This is the same strategy. So this will be what results in negative entropy. But guys, if a compound goes to the elements, a compound once a single unit form 2 or more units in the product, that increases the number of the moles, so it has a positive entropy. These are the three determination steps in order to determine the sign of the entropy. More examples, guys. For example, calcium carbonate solid goes to solid and gases. In this case, what to do? The solid goes to solid, the entropy unchanged, but the solid goes to the gaseous changes. So we will take the sign of solid goes to gaseous, it has a positive entropy. Another example, N2O4 gaseous goes to NO2 gaseous. 1 mole to 2 mole, so low to high, it has a positive entropy. A soda can closed goes to the soda can open. A closed can of carbonated beverage with the opened can of the carbonated beverage. Guys, as we open the can, what will happen to the movement of the CO2 in the can? It increases, escapes to the surrounding. So from the aqueous, it goes to the gases. That's why it has a positive entropy. According to the entropy, again, I would like to remind you that the favorite direction is positive entropy, and according to enthalpy, the favorite direction is the negative enthalpy. So processes in nature, we reach it to the free energy. We'll be talking about the Gibbs free energy, are driving in 2 directions. Usually in nature, the reactions, they have tendency to be toward the least entropy, means the enthalpy, the enthalpy is negative, and the largest entropy, which the delta is positive. So whenever a reaction has these 2 signs, a positive entropy and a negative enthalpy, always becomes a spontaneous reaction. We'll be talking about this in a table. As a way to predict which factor will dominate for a given system, a function has been defined to relate the enthalpy and entropy factors at a given temperature and constant pressure. Guys, we may have different signs of enthalpy and entropies. We have 4 cases. We'll be talking about it in detail. What if the sign of the entropy is negative and enthalpy is negative? Or enthalpy is positive and entropy is positive? Enthalpy is positive, entropy is negative. What if? So another factor must be taken into consideration to predict the spontaneity. So from now on, we do not determine the spontaneity of the reactions only from individual enthalpies or the entropies. Instead, we have to combine both driving forces in a combined equation, and that combined equation is a free Gibbs energy. Enthalpy change is the change in energy of reaction. Randomness of the reaction is the entropy. So this combination of the enthalpy entropy function is called the free energy, or represents by G, guys, of the system is called the Gibbs free energy. The scientist who called Gibbs derived this equation in order to process the spontaneity of reaction. Which sign of the G or delta G, we can say, we'll be talking about the change in G must be calculated. Which sign of G represents or results as spontaneous? Of course, a lower delta G or negative delta G represents what? Spontaneous reactions. Guys, we said enthalpy change, only the change in enthalpy can be calculated previously. As the enthalpy change, the Gibbs free energy or the free energy, only change in free energy can be measured. It can be defined in terms of changes in enthalpy and entropy. So we combine both entropy and enthalpy with temperature as well in a reaction. Here the reaction is given. And we'll be able to calculate the free Gibbs energy. At a constant pressure and temperature, the free Gibbs energy change, delta G, is what? Is the difference between the change in enthalpy and the product of the Kelvin temperature and entropy change, which is given here is the equation. And this equation must be memorized, guys. So delta G, standard Gibbs free energy, equals to the enthalpy at standard temperature and pressure minus temperature delta S at standard state. The unit of delta G and delta H, both they have what? Kilojoule per mole, but the unit of delta S is kilojoule per mole Kelvin. You have to know the units. And the unit of the T is Kelvin in this case. Which possibilities do we have? 3 possibilities for the reactions for delta G. If delta G positive or negative or 0, what will happen? Guys, if delta G is lower than 0, or we can say negative, this represents the spontaneous reaction. So the reaction occurs spontaneously. Or we can say T delta S higher than delta H. In this case, it represents a spontaneous reaction. If, guys, delta G higher than 0 or delta G positive, we can say T delta S lower than delta H, reaction does not occur spontaneously, becomes non-spontaneous. What if 0 delta S is equals to delta H? The reaction we call the reaction is at equilibrium, neither spontaneous nor non-spontaneous. Both possibilities are equal. We have got 4 signs of temperature, 4 signs of enthalpy and entropy. In each sign, let us determine what will happen to the enthalpy, what will happen to the spontaneity. I have provided the notes here, but let me show you how to determine, without memorizing this table, how to determine the sign of the Gibbs free energy, and how to know which case, whenever the spontaneous reaction the reaction becomes spontaneous or non-spontaneous. Have a look, guys. Here we need just the signs of enthalpy and entropy, and then we'll predict the sign of delta H. We have got four combinations, 1, 2, 3, 4 combinations of the signs. The first one, negative enthalpy, positive entropy. The second one, both negative. The third one, both positive. The fourth one, positive enthalpy, negative entropy. Let me show you the first one, how we can predict the sign of the enthalpy, or the sign of the Gibbs free energy. Sorry, guys. Write the equation first. Delta G is equal to delta H minus T delta S. Just take the signs, negative and positive, negative and positive. So here, negative entropy and positive enthalpy. Negative enthalpy and positive entropy. If we take the sign of enthalpy, enthalpy is negative, you know that. But the sign of the entropy, we have a negative. Negative multiplied by the positive, we have a negative also. Also, whenever we add two negative values, two negative numbers, always results a negative. So always delta G is negative. Delta G is negative. And we can say always the reaction is spontaneous. As you can say, always the delta G is negative and the reaction always is spontaneous or never non-spontaneous. In this case, always the reaction is spontaneous. Let me show you the second. Let me show you the second, guys. The second case. Write again the delta G equals delta H minus T delta S, guys. Negative, negative, if both are negative. Let me show you what will happen if both are negative. Negative and negative. Guys, according to the enthalpy is negative. Negative multiplying negative is positive. Whenever we have two numbers, two values with different signs, there will be possibility for both. If we add a negative with positive, if the negative is higher than the positive, results a negative value, addition of those two. If the positive is higher, amount of the positive is higher than the negative, when we add them together, the positive dominates and the result takes the positive value. So we can say that, let me tell you when it be negative, when it be positive. Guys, if we take the sign of the enthalpy, what will be the delta G? So if the enthalpy is higher than T delta S, the sign of T delta S is positive. Delta G is negative. Why? Because that will take the enthalpy change sign, which is negative. And we can say in terms of T lower than enthalpy over entropy, the sign of delta G is negative. So at low temperature, so it's given, guys, negative at lower temperature, or we can say spontaneous at low T, or T delta S lower than delta H. T delta S lower than delta H, or T lower than the enthalpy over entropy is spontaneous. When it will be non-spontaneous? If T delta S positive higher than the delta H, and if T higher than enthalpy over entropy, at high temperature this reaction is non-spontaneous. Let me show you the third one, two positives. Delta G equals delta H minus T delta S. Positive, guys. This is the opposite of the second case, which here the enthalpy is positive plus the positive multiply negative, you get a negative value. So if we take the sign of T delta S, results what? A negative value of delta G. and that will be spontaneous. In this case, if T delta S higher than delta H, the delta G will be negative, and then it will be spontaneous. Or we can say T higher than delta H over delta S at high temperature, negative at high temperature, spontaneous at high temperature. T delta S higher than delta H is spontaneous. The reverse is non-spontaneous. At low temperature is non-spontaneous. This case, when delta H is higher than T delta S is non-spontaneous. That's how we can determine the spontaneity. The last case, I would like to represent also the last case to you. Delta G is equal to delta H minus T delta S. So guys, in this case, the enthalpy is positive and entropy is negative. Positive and negative. Let us calculate mathematically a positive value of delta H plus negative multiply negative positive. If we add two positive values, always becomes positive, so never negative, or we can say always non-spontaneous, or never spontaneous. This reaction is never spontaneous. These are the four cases. Simply by this technique, you will be able to manage the sign or determine the sign of the entropy. Here we have some notes, guys. If delta H and delta S are same temperature has effect, and the same sign means negative and positive. If their signs are equal, are the same, temperature in that case has effect, and it determines at high temperature or low temperature delta G becomes positive. Is same as delta H at low temperature. If delta H and delta S are different sign, temperature has no effect on the delta G. Temperature, the first and the last, which the signs were opposite, we didn't say temperature at low temperature or high temperature. We said the first always spontaneous, the last never spontaneous. But the second and the third, which the same sign is positive, negative, the temperature decides. And temperature plays important role in whenever the signs are equal. If enthalpy and entropy changes, guys, if enthalpy and entropy changes are negative both. Enthalpy change negative, entropy change negative. According to which of them we can say it's spontaneous, guys? Delta G is equal to delta H minus T delta S. Negative and positive, negative and negative. If we take the sign of enthalpy, well, let's the delta G negative, spontaneous. But negative multiply negative, positive. We take the sign of the entropy, it will be non-spontaneous. So according to which of them, in this case, let's the spontaneous, the delta G be negative, according to the enthalpy. Enthalpy leads to a spontaneous, and entropy leads to a non-spontaneity. And entropy, if both changes are positive, enthalpy leads to non-spontaneity. If both positives, guys, delta G equals delta H minus T delta S. Positive. According to enthalpy is non-spontaneous, but negative multiply positive, negative, according to entropy in this case is spontaneous. So whenever both are negative, enthalpy leads to spontaneity, entropy to non-spontaneity. Whenever they are both positives, entropy leads to spontaneity, enthalpy leads to non-spontaneity. But guys, if both changes are different in sign, both equally leads to spontaneity and non-spontaneity as well. So we can say that when they have different signs, they both lead to spontaneous together or non-spontaneous together. Have a look. Delta G equals delta H minus T delta S. For example, negative, positive, okay? According to enthalpy, it's spontaneous. Negative multiplied positive is negative. According to entropy, also non-spontaneous. Let me determine by positive and negative. According to enthalpy, positive, delta G, if we take the sign of delta H, is positive and is non-spontaneous. Negative multiply negative, positive, according to entropy, also non-spontaneous. So you have to know that when the enthalpy is, when both are the same, negative enthalpy leads to spontaneous, positive. Entropy leads to spontaneous. If they are different, both they leads to spontaneous or non-spontaneous together. Here we have examples, guys, some examples about those notes we said. We'll be solving the notes, but let us talk about manufacture of syngas, guys. A mixture of carbon monoxide and hydrogen has positive enthalpy, gives free energy and entropy as well. And then, guys, the manufacture of the formation of the syngas can be formed from the reaction of methane with H2O, which would form carbon monoxide and H2. Both these two gases we call as the syngas, which the process has all negative, positive enthalpy, positive entropy. This should be entropy as well, and positive enthalpy. Here we have got a question, a sample problem set. For the reaction of NH4Cl goes to NH3 and HCl at 298 Kelvin. Enthalpy is positive 176. Entropy is 0.285. Calculate delta G. So simply just write the equation, guys. Equation is equal to delta H minus T delta S. Delta H is what? 176 minus 298, which is the temperature of the reaction, and multiply to 0.285, results what? Positive delta G. So delta G here is positive, that means this reaction is non-spontaneous. This reaction is what? Is non-spontaneous. The practice, guys, this was the ministerial exam question as well. For the vaporization of reaction of Br2 to Br2 gaseous, the liquid goes to gaseous. The enthalpy is 31 kilojoule per mole. The entropy is 93 joule per mole Kelvin. At what temperature will this process be spontaneous? Guys, to solve such reaction, just write the equation. Delta G is equal to delta H minus T delta S. And then set at which temperature. So it's required to find the temperature. As you can see the both signs are positive enthalpy, positive entropy. So just let the positive here. We will be able to determine the case at which temperature it will be spontaneous. Negative multiply positive, it will be negative plus positive value. If we take the T delta S higher than delta H, it will be spontaneous. T delta S higher than delta H. Or in terms of T, divide both sides by delta S. T higher than delta H over delta S. This will result a spontaneous reaction. But guys, let us divide the values of delta H over delta S. So we can say T higher than delta H is 31 kilojoule per mole. But guys, the delta S, be careful about the unit, it's joule. You have to convert into kilojoule by multiplying by 1,000 dividing by 1,000, sorry. You'll get what? A value of 0.093 when you divide it, 0.093 kilojoule per mole Kelvin. So kilojoule per mole, cancel it, the Kelvin is a reminder. So 31, if temperature above this value, that will result as spontaneous reaction. If it's below this value, the temperature, a non-spontaneous. If it's in this value exactly, that will result as 0, delta G, and equilibrium. So T above 333 Kelvin process can be spontaneous. That's the procedure how we can determine the temperature. There are some questions, let us answer those questions as well. This endothermic reaction, so endothermic means the enthalpy change is positive. A is what? A, B, C, D is given, the options, but let us determine the sign of entropy as well. Solid goes to gas, so the entropy is positive as well. Delta G equals delta H minus T delta S, guys. Positive, positive, negative multiply positive is negative, sorry, and plus positive. So when it will be spontaneous at low temperature, spontaneous at low temperature. Or at high temperature, sorry, this side must be higher than the other side. So T delta S higher than delta H will be spontaneous, or T higher than the division of the delta H to the delta S is spontaneous. So it's spontaneous at high temperature. C is the correct answer. The other question, guys, the sign of delta S is required. Gas goes to liquid, so gas to liquid is the reverse process of backing the gas to the liquid. It has what? It has a negative entropy. In which one temperature has no effect on delta G? Guys, whenever the signs are equal, temperature has effect. That means choose one of them when the sign of enthalpy and entropy are different. This is endothermic, so delta H is positive, and S goes to gas, and delta S is what? Solid goes to gas, delta S is positive. Positive, positive, so it's not correct. Why? Because the signs are the same, temperature has effect. The same, delta H is positive, the second, positive. Liquid goes to gas, delta S is positive. So again, it's not correct. Why? Because both are positives, both signs. Here, the third one, delta H is negative. Why? Because energy is in the product. And the solid goes to aqueous, delta S is positive. So different signs, yes, in different sign, temperature has no effect on the Gibbs free energy. That's the end of the section, guys. Now I will be solving the standardized test prep. This is the test bank. It needs time to solve, and we have ministry exam questions as well. Let us solve some of the ministerial exam questions by decreasing pressure on a given gas sample. So guys, about the pressure, whenever we decrease the pressure or increase pressure, there will be change on the movement of particles in a system. Let me show you what will happen to the entropy. When the particles are moving freely, they are in high entropy. But when we pressurize them, that means we limit their movement and they be more ordered, and the entropy reduces. So decreasing pressure means letting the gases to move freely. As they move freely, they have a positive entropy. A positive entropy, what is delta S higher than 0. The following reaction is exothermic. Exothermic means what? Delta H is negative. Which of the following statement is true about the reaction? A gas goes to gas, but 2 moles to 1 mole. So delta S is what? Is negative as well. Why? Because a high mole goes to the low mole. It reduces the entropy. Just by practicing the same technique, guys, minus T delta S, negative, negative, so negative multiply negative, positive, and T or delta H higher than T delta S, or at low temperature it's spontaneous. The reaction is always spontaneous, is always non-spontaneous. Spontaneous at low temperature, yes, at low temperature it is spontaneous. This exothermic reaction, exothermic means negative entropy, negative enthalpy, sorry, and the gas goes to gas. Here we have got the status cannot be used to determine the entropy, and the moles there 1. So how many moles do we have? 2 goes to what? To 1 mole of the gases. That means the negative entropy as well. The same case as the other one. It's spontaneous at low temperature whenever both are negatives, guys. According to randomness, the reverse reaction is favored. According to randomness. Randomness, entropy, which direction is favored? The positive entropy. So, which direction is the reverse reaction must have a positive entropy. Here, the solid goes to aqueous, is the forward is positive entropy. The forward is positive. So the reverse is negative. So it's not A. Liquid goes to gas, the delta S is positive forward, but the reverse is negative. Gas and liquid goes to aqueous. So gas goes to aqueous. We do not count the liquid goes to the aqueous. Why? Because the gas reduces to aqueous. So it's what? It has an entropy of negative entropy. Why? Because gases goes to aqueous. This is the forward negative. The forward negative entropy. How about reverse? Positive entropy. So this one, the reverse favored according to the entropy. Which of the following substances that has higher entropy? The solid, liquid, gas, high entropy gas, of course. Which of the following statement is always true for a spontaneous process? Spontaneous process, a positive entropy, negative enthalpy. Positive entropy, negative enthalpy is always spontaneous. The reaction is more spontaneous by greater positive value of what? More spontaneous by greater positive value of which of them? Delta S, delta G, delta ST. Spontaneity determines by having a greater positive value of entropy. Yes, of course, the entropy must be more positive to be spontaneous. Guys, a non-spontaneous reaction that occurs as a result of increasing temperature must be endothermic and more random, endothermic and less random, exothermic and more random, exothermic and less random. This reaction said the non-spontaneous reaction that occurs as a result of increasing temperature. The reaction is non-spontaneous, so delta G is positive, okay? Occur as a result of increasing temperature. So delta G is equal to delta H minus T delta S. In which case the Gibbs free energy is non-spontaneous, but it becomes spontaneous because of increasing temperature. Let us test the cases. Of course, must be the same signs. Why? Because temperature has effect when the signs are equal. Let us test both possibilities of positive. At a higher temperature must be what? Must be spontaneous. The reaction must change to spontaneous. So positive multiplying negative is negative and is positive. In this case, at high temperature, the reaction becomes spontaneous. So a non-spontaneous reaction that becomes spontaneous as a result of increasing temperature is this case. Positive entropy, positive enthalpy. So endothermic and more random. Yes, endothermic and more random. Why? Because endothermic means it has a positive enthalpy. More random means it has a positive entropy. Another question, guys. Delta S is given, but in joule, you have to know to change this to kilojoule, guys, for this reaction, and the enthalpy is given. Calculate the delta G for until whether this reaction is spontaneous at 298 Kelvin or not. Guys, you have to calculate by putting the number 3 joules per Kelvin changes to kilojoules, and then this is to the enthalpy, the negative enthalpy, this negative, and then you'll be able to solve the question like that. I have no calculator, that's why I cannot solve the question, but delta G is equal to delta H is minus 393.51 minus 298 multiplied by what? By 0.003 joules, because this is 3 joules, 3 kilojoules, sorry guys. We have to divide by 1000 to become kilojoule per mole Kelvin, okay? That will result in what? Delta G, and then if it is negative, yes, you can say it's spontaneous. If it's positive, no, it's non-spontaneous. That's how we can solve the reaction. Here we have got 5 questions. We'll be solving the 5 questions, and then later I'll be solving 50 questions on the chapter 4 to revise both sections in as quickly as possible. The first one, which of the following 2 conditions will favor a spontaneous reaction? The conditions of having a positive entropy and a negative enthalpy, an increase in entropy and decrease in enthalpy. Yes, A is the correct answer, which is the increase in entropy, positive entropy, and a decrease in enthalpy. The gasification of coal is a method of producing methane by the following reaction: carbon plus 2H2 formed methane. Find the enthalpy of the reaction when these steps are given. Guys, by Hess's law, simply we can solve the question. The carbon in the step 1, 2, 3. Carbon is in the reactant, there in the reactant, 1 mole, so unchanged the first enthalpy. Second, the hydrogen is in the reactant, there is in the reactant, but here 1 mole, there 2 mole, so multiply this by 2. And methane is in the product in the main equation, and here is in the reactant, just reverse it. It's negative, it will be positive. So add them together, you'll get the value of the enthalpy, as I know it's the negative 75B is the correct answer. So 2 metals of equal masses but different specific heat absorb the same amount of heat. So the amount of heat and the masses are equal. Q and M are equal. The relation is between Cp and delta T. Cp equals Q over M delta T, guys. If 2 are constant, these 2 are constant, what's the relation between Cp and delta T? Is inversely proportional, of course. The metal, which one undergo a smaller change in delta T? A smaller change in delta T must have a higher Cp. So the metal with the higher Cp specific heat is the correct answer. A is the correct answer, guys. Which of the following process has a negative entropy? Evaporation, liquid to gas, no, it's positive. Raising the temperature, increasing temperature of a system, increases the motion, increases the entropy, no. Freezing means what? Means liquid to solid, yes, C is the correct answer. The 5th question, the 5th one, said at a constant pressure, the following reaction is exothermic. Exothermic means delta H is negative, and it's 2NO2 gaseous goes to N2O4 gaseous. 2 mole goes to 1 mole. That means delta S is negative as well. Which of the following statement is true about the reaction as written? Delta G is equal to what? Delta H minus T delta S, negative, negative, negative multiply negative, positive, positive plus negative. So the reaction is spontaneous at low temperature. This T delta S must be lower than delta H. The reaction is always spontaneous? No. The reaction is spontaneous at low temperature? Yes. B is the correct answer. Now we will be solving the 40 questions which we call as the BAL, Beyond All Limits, guys, for the chapter 4, in order to revise the chapter 4 for these questions, guys. Is the study of transferring of energy as heat that accompany chemical reaction and physical change. Study of transferring of heat is what? Is thermochemistry, guys. The greater the kinetic energy of particles in a sample, the higher the temperature, of course. The temperature should be higher. A greater kinetic energy represents a higher temperature, so C and D cancel out. And the hot or the cold it feels, a greater kinetic energy has a higher temperature, and the hotter it feels, so B is the correct answer. The higher temperature and the hotter it feels. Which of the following is not a unit of heat? Is not a unit of heat. Joule is unit of heat. Newton multiply meter is unit of heat. Kilogram, can be stated as kilogram meter per second square, and multiply meter, it will be kilogram meter square per second square. Another unit is correct. But the last one, kilogram meter per second square, it's not the unit of Joule, it's the unit of Newton. Energy transferred as heat always moves spontaneously from what? From a lower temperature to a higher temperature? No. From a hot object to a cold object? Yes. From a higher temperature to a lower temperature? Yes. So B and C, they are both equal. Both true. Is the same amount of energy required to raise the temperature is an amount of energy required of 1 gram of a substance by 1 Celsius or 1 Kelvin. Of course, this is a specific heat which represents the absorption capacity of the elements. Specific heat measure under constant, so its symbol is Cp. That's under constant pressure. C is the correct answer. Which of the following is not a unit of a specific heat? We said there are 3 units of specific heat. Joule per gram Celsius, its unit. Joule per gram Kelvin, its unit. Calorie per gram Celsius, its unit. Calorie per gram Joule, it's not the unit. D is the correct answer. Enthalpy of reaction does not depend on temperature. B. A thermochemical equation is what? Is an equation which represents entropy change? No. An equation which represents enthalpy change of reaction? B is the correct answer. For an endothermic reaction, reactant is lower energy state than the product. Endothermic. Change in enthalpy results a positive value. Reactant is much stable than the product. Guys, endothermic, the reactant is in a lower position of energy. A is correct. The results a positive value is correct. Reactant is much stable is correct. Why? Because it's in a lower position of energy. So D is the correct answer. For an exothermic reaction, product is less stable than reactant. Product is less stable. Exothermic is not true. Enthalpy change results a negative value. Yes. Reactant is in a lower energy state? No. Exothermic reactant is in a higher position of energy. So B is the correct answer. D said energy must be added to the system? No. The amount of the energy absorbed by water molecule to form elements is the amount of energy released when elements combine to form water. Is the same. Is the same, guys. It's not twice or quadruple or threefold. Is equal to the amount of energy which needs, but with the opposite sign. Molar enthalpy of formation is what? Is a formation of 1 mole of a compound from the elements. B is the correct answer. Elements in the standard state are defined as having 0 enthalpy of formation. Which of the following values of enthalpy of formation represents highest stability? Highest stability, the most negative. -333, -2 for 1, positive, so positives are not, so A is the correct answer. Formation of which of the following results lowest instability? Lowest instability, that means highest stability. Of course, these 3 formations are positive, this is negative. The formation of H2O has a lowest instability or highest stability. D is correct answer. Its instability makes it useful as a detonator for explosive. Mercury fulminate. C is the correct answer. The usually enthalpy of formation of compounds is negative. Formation of which of the following is not negative, is positive? HiC2H2, HgC2N2O2, or all of them is correct. Why? Because these 3 formations are positives. Enthalpy of combustion is a complete combustion of 1 mole of a substance, or combustion of 1 mole of a substance with the highest amount of oxygen. B and C are both true. D is the correct answer. In which of the following all enthalpies are equal? We said the note that 1 mole of an element, 1 mole of an element combusted with the highest amount of oxygen to form a half mole of a compound. No, 1 mole of a compound formed from the complete combustion of its elements. Yes, the C is the correct answer. 2 objects has the same mass and CP. Which one absorb high amount of energy? This relation is between the Q and the CP. Of course, the one that added more heat will absorb more. So the one heated less, no, the one heated more, yeah. B is the correct answer. 2 substances have equal mass but different CP. Which one has a lower temperature? This was we solved in the standardized test prep. The one with the has lower temperature, the one with the higher CP has a lower temperature. The process of formation of a solution almost always increase the entropy. B is the correct answer. Mixing gases, dissolving a liquid in another liquid, dissolving solid in a liquid results a reduction in entropy. No. Does not affect entropy. No. Results in increase in entropy. C is the correct answer. This is the guys, the critical thinking of the section review. Most biological enzymes becomes denatured when they are heated and lose the ability to catalyze reactions. This process, the process is what? Is original enzyme goes to denatured enzyme is endothermic. So delta H is positive. And spontaneous means delta G is negative. Which structure, the original enzyme or the denatured enzyme, is more ordered? Of course, guys, we said in entropy that the orderness is just the reverse of the entropy. So delta G equals delta H minus T delta S. The sign of enthalpy is known, positive. The entropy is the Gibbs free energy is known is negative. How to determine the sign of the entropy? There are 2 possibilities, positive or negative, but let us check for both possibilities. Let us suppose it's positive. If these 2 are positive, is there possibility to delta G to be negative? Let us check. Negative multiply positive results a negative value plus positive. So yes, at a high temperature, this delta G can be possible. This is possible. But let us take the second, which is negative. If delta S is negative, and this is positive. Negative multiply negative results a positive value. Positive plus positive never spontaneous. So it's not the appropriate for this condition, which delta G is negative. So this tells us The delta S is positive. The delta S is positive. This process has a positive delta S. So means original enzyme to denature it has a positive delta S. But the original enzyme is more ordered than the denatured. The original enzyme is more ordered than the denatured. Why? Because the order sign reduces as the enthalpy increases. So the reactant is more ordered, yes, because reactant is original enzyme. The product is more ordered, no. Original enzyme is more ordered, yes. So A and C is a correct answer. The overall enthalpy change in a reaction is equal. This is the Hess's law, guys. This mathematical question you can solve. We solve with the mathematical questions, calculations. In the shown equation, the amount of heat produced is equal to what? This equation, 1 mole of carbon monoxide combusted with oxygen to form carbon dioxide. This is enthalpy of combustion of carbon monoxide? Yes. Enthalpy of formation of carbon monoxide? No. Enthalpy of formation of carbon dioxide? No. Enthalpy of combustion of carbon? No. A is the correct answer. The entropy of a pure crystalline solid is 0 at 0 Kelvin or minus 273 Celsius. 0 Kelvin, so D is the correct answer. The reaction of ethane with hydrogen which formed ethane has a negative enthalpy. Negative enthalpy means delta H is negative and entropy delta S is negative. Which factor leads a non-spontaneous process? We talked about them. This note, we said whenever the signs are the same, one of them leads to spontaneous, the other leads to non-spontaneous. When they are both negative, according to enthalpy leads to spontaneous, but according to entropy leads to non-spontaneous. Here requires to non-spontaneous, so entropy is the correct answer. Syngas is a mixture of carbon monoxide and oxygen, hydrogen gas. Carbon monoxide and hydrogen, which is D is the correct answer. In combustion reaction of methane releases this amount of energy, which is 206.6 kilojoule with an entropy of 0.215 kilojoule. The reaction is spontaneous due to both are positive. Delta H is positive, delta S is positive. Both are positives. According to enthalpy is non-spontaneous. According to entropy is spontaneous. So a reaction is spontaneous due to the entropy change. If it's non-spontaneous, due to the enthalpy change. A reaction has a positive enthalpy and negative entropy. This reaction is what? Positive enthalpy, delta G is equal to delta H minus T delta S. Positive enthalpy and negative entropy. Negative multiply negative is positive. Positive plus positive, always non-spontaneous or never spontaneous. Never spontaneous because always is positive. As pressure decreases on a system, the system, there will be more movement of particles, so what will happen to the entropy? Increase the entropy of the system. Which of the following two conditions will favor a spontaneous reaction? A favor spontaneous reaction, of course, increase in entropy and decrease in the enthalpy. A is the correct answer. Which of the following process has a negative delta S? This is the same as the standardized test. Freezing of 1 mole of liquid. C is the correct answer. At a constant pressure, the following reaction is exothermic. Which of the following statements is true about the reaction as given? This is another question in the standardized test prep, guys. We solved this. We said as the entropy negative and the enthalpy is negative, the reaction, both are negatives. The reaction is spontaneous at low temperature. The reaction is always spontaneous. No, the reaction is spontaneous at low temperature but not at high temperature. Yes. Interpretation questions, this will be the questions should be solved, and we have solved some of these questions. Thank you for the attention. That's the end of chapter 4.